So what is differential privacy, and how is the PrivateSQL that you've developed going to enable our audience here to make differential privacy SQL queries more easily?
Okay, great. That's a great question. So when we talk about privacy computing, actually there are several different aspects of privacy that we need to pay attention to. So the first, when I talk about fully homomorphic encryption and also secure multi-party computation, and also there's another type of approach using secure hardware, secure enclaves. So all these technologies, the goal is to protect the computation process from leaking sensitive information. So basically, the goal is to compute over encrypted data, but using different types of technologies. But another important aspect is, so for example, in this case, when somebody does a computation, the computation is based on the original sensitive input. So then we also need to ensure that the computation output doesn't leak sensitive information about the original input. So for example, some of our earlier work actually in this space also relates to these large language models. So we showed that with these large language models, and also it's not just unique to large language models. So I'm just using that as an example.
Sure.
So in general, these models, they have huge, deep learning models, they have huge capacity. So there's another question whether they actually remember training data. And if they do, whether attackers can actually extract the sensitive information from the original training data by just querying this model without even knowing the architecture or the parameters, these details of the model.
So GPT-3 could theoretically, if trained on private data, it could be memorizing those data, and then you could potentially write queries that would allow you to extract private information from a large language model like that.
Yes, absolutely. That's actually exactly what we did. So we did, right. Okay. So we did a number of experiments. So one interesting experiment we did, it was a smaller language model where we trained a language model over a data set called the Enron data set, which naturally contained...
The Enron dataset.
Yes. The Enron email dataset. So
okay.
We don't have time to go into that, but it relates to the Enron, the company, earlier, yes, there was a case. So that's how that data was made available.
Right.
And the Enron email dataset naturally contained users' social security numbers and credit card numbers. So our work shows that by when you train a language model over this data set, an attacker, by devising some new attacks, it can, from just querying the language model without knowing the details of the language model, can automatically extract the social security numbers and credit card numbers that were in the original training data set.
Wow. So
this is an example illustrating that as we train these large models, it's really important to pay attention to users' data privacy as well. And later on, we extended the work on larger language models as well, including GPT-2, and we are actually looking at some newer models, including the models in the category of stable diffusion and so on. So all these illustrating that as we compute over user-sensitive data, from the output, in this case, either it's the inference from a machine learning model, or it can be other analytics and so on. So for example, if we are computing analytics over users' data, then it's important that the computation output doesn't leak users' sensitive input. So then what's the solution to this? So today, actually, the gold standard is to make your algorithms differentially private. So differential privacy is a formal notion of privacy. At high level, what it says is the reason it's called differential privacy is, so for example, I have a data set, and then I have a neighboring data set with your data added to it, with your data point added to it.
Yeah.
And now I want to compute algorithm, either training a machine learning model or compute data analysis query over this data set. Actually, over these two neighboring data sets.
Okay.
And then my algorithm is randomized. So the results of this randomized algorithm over the data set will produce a probability distribution.
Okay.
So we say that my algorithm is differentially private if the probability distribution generated from my algorithm over these two neighboring data sets with or without your data points is indistinguishable to the attacker.
Right. So if there's a difference between the data sets, I guess that's where differential comes from.
Exactly.
But we can't tell a difference in these probability distributions that are computed from it.
Right. So if that is the case, that means then your data is pretty safe. In the sense that as an attacker, from just looking at the computation output, the attacker cannot tell whether your data is has been used in the computation or not. And so intuitively speaking, provides protection for your data.
I see.
So that's differential privacy.
Yes.
And in our work with Meta, so we also use differential privacy to protect the computation output from leaking sensitive information about users' input. And and a couple of things I can add.
Well, yeah. So I'd love to hear about the PrivateSQL that's related to this.
Right.
So,
Exactly.
Yeah.
So actually, from this experience, a couple of lessons that we have learned that I actually like to some of the follow-on work that I can share is, so overall, all these technologies, they are great, and there have been lots and lots of papers, maybe hundreds of papers or even more written on the topic. But most of the papers actually, mostly the great ideas have mainly been just sitting on the bookshelf. In the real world, in practice, we have seen very, very little real-world deployment of these great ideas, these great technologies.
Okay.
So for example, differential privacy, I think right now has been, so Google has done some special use case, and Apple has done some special use case using differential privacy. And these are the leaders in the space, in industry. And even in their case, it's still very specialized use cases. So overall, I think more and more people are hearing and learning about differential privacy, for example, but most people have never really, seen how it's deployed in the real world, know actually how to use it. So this started as research work in my research group at Berkeley, and then now Oasis Labs has been actually productizing it, making it actually as a commercial product, is to really solve this problem, is to make this differential privacy technology, in particular in this case, enabling differentially private SQL, to make it really easy to deploy, and hence more data scientists, more practitioners can benefit from this technology. So this also was motivated actually earlier from our collaboration with Uber. Actually,
with Uber, the rideshare company.
Yes, a few years back. So basically, for Uber, for example, and also lots of companies have this the same issue, is that they have a lot of sensitive users' data. And then this data, of course, can be very useful to provide business insights to help them improve their service for users, and also figure out how to best deploy their resources to improve their overall business. And so ideally, they want to have a lot of their either marketing departments or business departments and so on. So just in general, for their business operation, they want to have different analysts or even just people in these departments to be able to somehow use the data to gain business insights. But of course, given that this data is really sensitive, for example, Uber has, every user's rides data, from your start and location and time and so on. It's really sensitive information.
Yeah.
So then they can't give access to these, marketing departments and these other departments and so on. And in fact, actually, Uber in the past had fired employees.
Yeah, Uber is not famous for for being very good about privacy.
So in the past they had fired employees who actually misused their access rights to look up
God mode.
Right. Okay. So then essentially they're in a dilemma. So either they just lock down the access. So then they can't use the data. Their employees cannot use the data to improve the business and improve also user experience overall. Or if they give access, then they have this huge risk of privacy and data breach and so on.
Right.
So then in this case, actually PrivateSQL is actually a great solution for them. Because with the PrivateSQL, so also let me tell you a little bit in terms of the technology for PrivateSQL.
And so PrivateSQL, anyone here can use, right? It's
exactly. So that's a technology that Oasis Labs now is commercializing.
Oh, you're commercializing.
Right. So what it is again for differential privacy, as I mentioned, it's a formal notion of privacy, and you actually have to, for each algorithm, you have to develop a differentially private version of the algorithm. So for example, if you want to compute a count, if you want to compute like a sum or average and so on, you need to develop like a differentially private version of these analytics. And depending on the actual data set attributes, there are different differential privacy mechanisms that you can actually use. That's best for your privacy and utility trade-off. So in any case, usually it requires a lot of expertise in differential privacy to actually use it. But of course, most data analysts, they don't really know about differential privacy.
Right.
And also, it's difficult to, you also don't want to change the backend database to embed differential privacy mechanisms in the database because then it's difficult to actually deploy. You have to change the backend infrastructure. So what we have done with this PrivateSQL is basically you can view it as a layer in between the data analysts and the backend database. So basically it sits right in front of the backend database. So when users submit queries, this SQL data analytics queries, they will get automatically rewritten by our PrivateSQL this thing layer. And it will automatically write the SQL query into a new SQL query with differential privacy and other privacy mechanisms embedded into it. And then this new SQL query, we call it essentially intrinsically private query, then gets executed on the backend database. And then the database will return some results, and our thing layer will also do some post-processing in certain cases, and then in the end return the result. So the final result in this case will be guaranteed to be differentially private. And also, it can guarantee other privacy properties that your privacy policy dictates as well. So then in this way, as you can see, we've changed this deployment problem, making it really, really easy. So in this case, we don't change the workflow at all. Mm-hmm. So the data analyst doesn't need to know anything about differential privacy, and we don't change the backend database as well.
Perfect.
All you do is just put this thing there in front of the database, so it's really, really easy to deploy. And now, so in Uber's use case, now they can allow their analysts to use the data without worrying about data leakage, privacy violation, and so on.
Great.
So that's just one example of the real-world use case.
Yeah.
And we have the pilots now also with the BMW and also in healthcare with hospitals and so on. So
nice.
We do hope to actually bring this product to Google GCP and Amazon AWS very soon. So we hope that more companies and more data analysts, data scientists actually can benefit from